All right. So I'm looking at the chat box. All right, good deal. So so let's jump into this stuff really good. All right. So when applying correctly, to use pesticides successfully, you must apply the correct amount of pesticide over the target area in a uniform way. Errors in rate or uniformity may waste money, injure plants, damage the environment, fail to control the pest, and result in fines for illegal application. Something we don't want. In every situation, you should know rather than guess whether you are applying the correct amount of pesticide. Now, somebody mentioned calibration a while ago. Very good answer when it comes to applying the correct amount of pesticide. When should we calibrate our equipment?
Prior to use.
Do what?
Prior to use.
Prior to use, exactly. Every time we use the piece of equipment, we should do it.
Damn.
Uh-oh, somebody's got hot there.
But yeah, this microphone is a little stronger than I expected. I apologize.
No, you're right, man. But when we use the equipment, we should calibrate it. Who should be the one calibrating the equipment? The guy doing it. The user. Now, if you look back at some of our application manuals when we studied to get our pesticide exams, they're even saying you need to calibrate your equipment before the next job site. Now, we're not doing that. I mean, it's going to be hard. You don't want to pull up to someone's property and calibrate your equipment there on their yard. I mean, you want to get done and out, move on to the next one. And so, yes, we need to do it every single morning. The operator that's using it needs to do it every single morning. And with that, when are some other times you might want to think about calibrating your equipment? Because think about it. I know it's not so hot right now, but in the summertime, if we're making an application, you know, end of May, whatever, it's still warm. If we're having to do an application in July, when else should we possibly maybe want to calibrate that piece of equipment? Let's say we're behind and we're having to work, you know, long days. What do you think happens to us over the period of the day?
Gonna lose some chemicals, but heat.
Yes, heat. So what does that do to our body?
Evaporate and
Causes you to move faster.
Move slower. It changes our speed. So early morning applications, we may be, you know, walking our maximum speed. We've calibrated our equipment. We've gone and done a couple properties. We fertilized them. We've sprayed them, whatever we're doing. And we've maintained our walking speed. You know, we should be walking anywhere from, you know, probably, I don't know, 2 to 3 miles per hour, maybe on a good pace. What do you think happens to that pace? Let's say at 2 o'clock in the afternoon when we've had a lunch. We've slowed down. Our body has slowed down. And if we're trying to catch up yards because, you know, of weather or whatever, and our operators are, you know, moving through the day, they're going to get slower. They're going to get tireder. And so it may be beneficial. And I haven't done the math on this. I would love to sit down and actually calculate some numbers on this when it happens. If our operators are walking, you know, 2.5 miles an hour, you know, the morning applications, and they slow down to 1 mile per hour in the afternoon. Well, if that equipment was calibrated to walk 2.5 miles an hour, what do you think's happening when we're walking slower? What is that doing to our application rate?
Increases.
Is increasing, almost doubling it. And some of these chemicals that we put out on these properties get really, really expensive, especially fungicides. We don't want to actually waste any of that stuff. And that only not goes back to, you know, hurting our wallets and our pocketbooks, but it hurts the environment. We do not want to put out a pesticide more than the label calls for. For one, it's against the law. And second, you're wasting that money, and then you're hurting the environment. We want to take the responsibility and actually be stewards of the land and actually protect the environment, because we see enough negativity on our end because we are applying a pesticide. You know, that's one of the things that homeowners, you know, may or may not like, the general public may not like doing. And so when we're out there wasting the pesticide and actually putting more than we're needed, we're hurting the environment and we're hurting our profits. So when we are measuring the treatment area, most small sites are going to be measured in square feet. The larger sites, we're going to measure in acres. There are, you know, a lot of you guys probably are taking care of larger properties. So you're having to do it in, you know, pounds per acre, gallons per acre, whatever it is. Mistakes can get very costly in these larger sites. And a lot of the times we don't subtract out the areas that we are not treating. So we got to subtract out our driveways. We've got to subtract out our shrub beds. We need to subtract out the size of the house, the actual floor plan. Where can we get some of this information other than actually going to the job site and measuring it? Do most of you guys go and measure every single lawn care project that you're going to do? Or do you kind of have a set price that you're going to take care of this one neighborhood because pretty much every yard is the same size, pretty much the same builder built the house, so it's the same floor plan. They're off the same distance. Where's a good way to figure out how to measure these properties?
The label.
The what?
Label.
No, to actually measure the properties, our sites that we're going to apply the fertilizer or pesticide.
Okay.
Through GIS.
GIS is a great place to figure that out. Some of them actually, you can trace it and it'll give you the square footage. If not, there's paid services that you can do, like iGo Lawn, stuff like that, but you can get most of them. And it depends on where you're at. Most larger cities and larger counties are going to have a great GIS system. You know,
But
some of the
there still
rural
is a good margin of error though between when you click on those points and actually going and measuring the site itself.
Yes, it can be. Yes.
That's true.
Yep.
It give you a good idea, I guess. Not a perfect.
Yes, exactly. And after you've done 2 or 3 in a neighborhood, you're going to find out that pretty much most of them are the same size lots. They're going to be the same size, you know, turf grass that's on there. They're going to have similar driveway sizes or whatever, unless somebody's got, you know, a half circle in the front or whatever. But you can kind of get the idea of what certain neighborhoods are going to actually run. All right, and so here we actually have some geometric shapes, and basically we're looking at a golf course tee, or actually a hole. We've got the tee box, we've got the fairway, and then we've actually got our you know, our hole right here. So we're driving this way. And so the basic geometric shapes, and yes, I know this is a basic review, but it's something that we probably just need to touch base on every so often, especially if you got like a trapezoid area down there. That can get a little difficult. But if we have a circular patch of turf, the area of a circle is the radius squared, and then multiply it by 3.14, which is called pi, and that is always a constant. Rectangle, easiest one out there, length times width. Triangle is base times the height divided by 2, or 1/2 times the height. Multiply the base by the height and then divide by the 2. The trapezoid area is your A plus your B divided by 2 times your height. So A plus B divided by 2 multiplied by the height right here. So easy enough. The area of the golf course hole above can be divided into the circle, the rectangle, the triangle, and the trapezoid here. Total area of the individual areas is A plus B plus C plus D. So A being our circle, we have a radius of 70 feet. What does that make the diameter? 140. And so we've got pi, which is constant, times r squared, the 70 times the 70. It's going to give us 15,386 feet. B is our rectangle. We have 170 feet this way, multiplied by the 90 feet in the width. That's very simple. 15,300. Our triangle is 90 feet. Base here times the 50 and the height divided by 2. We only have 2,250 square feet. D, our trapezoid, we have 115 feet right here, plus the 140 over here, divided by 2 times the 40, the height, gives us 5,100 square feet. So a total of 38,036 square feet. So almost an acre, about 5,000 short of an acre golf course, tee box, fairway, and the hole and the putting green. The process of measuring output and adjusting your equipment to apply the right amount of pesticide to the target is calibration. Completed by the individual making applications and then properly calibrated equipment will deliver the right amount of pesticide each and every time. It'll apply it uniformly. And so, yes, you calibrate in the mornings. You may want to calibrate in the afternoon, right after lunch, because your guys are going to slow down. You need to calibrate it each time you pull it out of the shed. Before the season, it's good to teach your operators or your technicians out there on actually how to do it. It's real simple. It doesn't take as long. Another math that I would love to sit down and do is actually, how long does it take you to calibrate your truck sprayer, your boom sprayer, your backpack sprayer, your push spreader? How long does it take to do this every single day? What it is in man hours that you're going to spend in doing that, but compare it to the cost of losing the extra pesticide that you don't need to. It would be good to actually see that. But when we calibrate our equipment every morning, what's one thing we need to do with our equipment every single evening when we come in?
Flush it.
Wash it, clean it, and get it ready to go the next day. Good job, Heath. I see the chat's coming in. But that's exactly what you've got to do. You've got to clean it every single night. And some of these cooler nights or whatever, if you're doing a late winter application in December, what's something you need to do with some of these diaphragms and stuff? What do you not want to happen to them after you clean it?
Really?
Drain them. Exactly. You want to make sure that there's no water left in it in case there's a chance of a freeze or whatever. Or you'd want to keep them in the shop where it's not going to get so cold outside. The label will tell you the application rate. You've got to find it on the label. Examples that we may see in lawn care is 4 ounces per 1,000 square feet. That's called product per area. We may see 3 ounces per gallon. That's product per volume, And then we may see something like a 2% or a 2% solution, and that's percent solution mixed with water. And I know when we buy our pesticides, they're going to, come with a label attached to the packaging or whatever. It's going to be attached to the bottle. But it's always good to print some off the internet or, save them to your phone. Everybody carries around, pretty much a smartphone. Have that label on there or print it out. I don't like reading so much stuff on my phone. I'd rather have it printed out. That way I can circle things, I can highlight it or do whatever. And I keep everything that we spray or put out granularly, I keep in a 3-ring binder in the truck. That way I've got it every single time. A lot of that information can also be picked up from your dealers. When you go to Site One or if you go to Green Resource or whatever, ask them, say, hey, do you have a label for this? Do you have an extra label or whatever? A lot of the times the manufacturers have given them that documentation. They're ready to give that out to you. The label's what's printed on the bottle or the bag. What is all this other information that they can give you about the product called?
MSDS?
Well, yeah, that'll be included. Yeah, you can get an MSDS sheet from them, but you'll have the label that's attached to the bottle, and then they'll give you pamphlets. They'll give you an extra, and actually the label's a part of this too. But they can give you that extra label that's in a nice pamphlet or a brochure with an MSDS sheet. They may have some other documentation that they can give you about that pesticide, but that stuff's called the labeling. You have the label, which is attached to the bottle or the packaging, and then you have the labeling, which is all the other information that you can pick up from your dealers or the ag agents. Sometimes the ag agents will have that information. By the way, do we have any ag agents on board? Sometimes they jump in, jump out. They just pop in and listen sometimes. All right, it's a good deal. Just checking out. It looks like a couple people jumped out of the Zoom room. All right, so when to calibrate? Again, we've already talked about that. Before using it the first time of each year, when changing the type of pesticide, again, we may have a different truck that's going to apply a certain chemical in the morning. They may go back out in the afternoons. They need to recalibrate their equipment. When changing the rate and speed at which it is applied, that all has to do with launch. That has to do with the operator. Another time, I swear, I've seen it happen time and time again. When your technicians are late in the day, even though it's hot, they've slowed down at 2 o'clock. They've had a heavy lunch. But what also starts to happen around 4:30?
Ready to go home.
They're ready to go home, ain't they? So what do you think they're doing? They get that second wind.
Slacking.
They do slack, but they're slacking. They may pick up that extra pace. They might be walking 4 miles an hour.
That's
because they want to get the job done and get home. When they're walking 4 miles an hour, they're walking faster, and they've calibrated their equipment that morning for, let's say, 2.5 miles an hour. What do you think's happening to that yard? What's it not getting?
Enough product. Now, that creates another situation where, is it more expensive to apply less pesticide, or is it costing you more money to put out more pesticide?
Gotta come back.
You got to go back. The customer is not happy. They put in a complaint, called your office and said, hey, my weeds aren't dead. I need you to come back and do it again.
I hear that so much.
Do I?
Service.
The reservice? Well, usually that technician, if he has to go back out, he or she goes back out to that job site, what else is going to, what's going to happen? They're going to put out more pesticide than needed, probably. They're going to give it an extra dose this time. So you've not only done it once, you've gone back twice, and the technician's putting out probably more than it's needed. Anyway, they've sometimes more than doubled the amount of pesticide needed.
Overburn.
They what?
Overburn.
Overburned it. Exactly. We still got guys out in the field right now working and calling. But when equipment is moved from one site to another, I just don't see us doing that. There's no way that we can actually take that piece of equipment, calibrate it on the customer's job site, and do it. We're not going to do it. But it is especially important with rotary spreaders because their settings are easily knocked out of place. Why is that? Why does that happen with rotary spreaders so much? They're in the back of the... They what, Matt?
They get kicked around. They're just moved around on the trucks and stuff.
Yeah, exactly. They're sitting in the back of the truck, it's bouncing up and down, crossing railroad tracks, speed bumps or whatever. It's just going to happen. I've even seen it happen, even though we got the receiver hitch, holders that'll put the spreader on the back, set it in there. They can still get knocked out a little bit. So when we calibrate, we're performing safety. We're doing our speed distancing, 2 to 3 miles per hour walking, 4 to 6 mile an hour driving. Here's just a diagram stating that doubling your speed applies half as many gallons per acre. Same thing when walking behind a push spreader. If our individuals are flying at the end of the day, rushing to get home, they're not putting enough product out. Our handheld and backpacks, they're going to have compressed air up to 30 PSI. Now, guys, I'll tell you straight up, I love a backpack sprayer. I do. I love pushing my fertilize out, and I love backpack spraying my weeds. Some of our yards are very, very small. That's why I like doing it. I don't like even pulling a hose out. We tried the whole permagreen things and everything. Our system just works better with push spreaders and backpack sprayers in a small truck tank. When using these backpacks, though, the main reason I like it is because we can target the area that we want to use. Everything is separate. A lot of people are mixing their liquid fertilizer, they're mixing their pre-emergent, and they're even throwing in a broadleaf herbicide, especially in the spring. Well, what if this lawn doesn't have very many broadleaf weeds, and they're doing a broadcast application of a broadleaf herbicide? There's no weeds there. They're spraying the entire yard. They're applying the pesticide where it's not needed, which is against the label, against the law. Second, they're wasting money. And third, they're not being a steward of the land. And all your big chemical companies say, well, you know, we've done the math. It's a lot easier just to walk over the turf grass one time and spray it all out at once. I still don't see it, especially with some of these costs in chemicals. You can run to the truck, grab the backpack, hit that small patch of clover in the back because that's all you saw, and not make a broadcast application. So I love the backpack. These pressure will drop as the solution is sprayed. You got to make sure you keep it pumped up. If you have the gauge, keep it within 10 PSI of your initial pressure and when you calibrate. It's very easy to calibrate these backpacks. All you need is a little bit of water and some gravel, you know, gravel driveway or whatever, where you can see the water hitting it, and you can do it really fast. So calibrating it by the area, if you're applying the pesticide to an area measured in square feet, you calibrate the sprayer by staking out a 1,000 square foot test plot. So example, if we had a 20 by 50 area, we do it on a surface simpler, you know, to the treatment site. And what that means is it needs, if it's a flat yard, you need to have a flat surface. If you're kind of doing some hills or whatever, do it on a hilly slope or whatever. You need to walk the same type of terrain that you're going to be calibrating. But 1,000 square feet, very easy to do. Step one is you're going to fill the sprayer half full with water, no pesticide in it. The only time that we're going to calibrate a piece of equipment with the product we're using is if we're doing like a granular spread, you know, doing the rotary spreaders. We fill the sprayer half full of water, maintain the pumping pressure that you will use during the application. Then record the number of seconds it takes to spray the test plot evenly while walking at a comfortable, steady pace.
Question for you.
Yes, sir.
Do you like to put dye in there to see, making sure you hit everything?
If it's on your property, yeah, I mean, that's fine. But if you're doing it like on a gravel parking lot or even like on an asphalt driveway, you know, asphalt parking lot at your shop, you'll be able to see the wet pattern that you've sprayed. You know, especially early morning or whatever. Now, if it's like 1 o'clock or whatever, I mean, you know, it may evaporate very quick, but I think you should be able to see it with just the water. But if you wanted to use like tracker dye or whatever, that's.
Well, I just had a big job and with big tanks and so much area that I figured the green dye would be efficient to make sure I didn't miss that.
Yeah, yeah. Now are you talking about? Oh, so you're talking about, you know, actually using the tracker dye when you actually spray someone's lawn? And that,
no, I mean big tank area where they got the big tanks, you know, asphalt company, and I put the dye in there.
Oh, okay.
Make sure I didn't miss nothing, you know.
Yeah.
You can get overwhelmed when you got so much to spray.
Yeah, if I did it, I would do it very, very lightly. And a lot of the times, though, what happens is people they'll overspray and they'll get a little bit on the curb and gutter, and then you see that blue tracker dye on the asphalt or the concrete.
I was talking about a tank area, you know.
The what areas?
Tank area where they got big tanks with rocks, you know, and make sure the water behind the tanks, if they blow up, the fluids don't go out, you know.
Gotcha.
Okay.
But maintain your pumping pressure that you'll use during your application. Record the number of seconds it's to spray the test plot, that 1,000 square foot plot, while walking at the steady pace. And it's a good idea to spray the test plot 2 or 3 times and figure the average time. Use the average time in your calibration. So if you did it 3 times and it's taking you 30 seconds, 29 seconds,
And in 28 seconds, you would take 29 for the average. Step 2, you will stand still and you will spray into the container the average time found in step 1. The number of ounces collected equals the amount of spray delivered to 1,000 square feet. With this number, you can calculate the amount of pesticide and water need to treat the target area. And we actually have a problem to look at. So the labeled application rate states that 2 ounces of herbicide are to be mixed with a sufficient amount of water to treat 1,000 square feet. This can be expressed as 2 ounces per 1,000 square feet. We're actually applying a herbicide to a lawn that's 40 by 65 feet. Area to be treated is the 40 by 65, so we have a 2,600 square foot lawn. The test plot time to cover the 1,000 square feet is 80 seconds. The amount of water collected in our 80 seconds is 57 ounces. So our sprayer output is 57 ounces per 1,000 square feet. So to determine the total spray mixture that we need, we're going to multiply the target area by the sprayer output. So 2,600 square feet times 57 ounces per 1,000 square feet. It's going to give us 148,200 ounces over the 1,000. Our square feet cancels out. We have 148.2 ounces. We're rounding off to 148. We always round down instead of up. That way we're not applying more than necessary. To determine the amount of herbicide needed. So we figured out how much total spray mixture we need. Now we figure out how much herbicide we need. Multiply the target area, which is our 2,600 square foot lawn, by the labeled application rate. 2,600 times 2 ounces per 1,000 square feet cancels out. We have 5,200 ounces divided by 1,000 gives us 5.2 ounces of herbicide. So to treat that target area of a 40 by 65-foot lawn, we're going to use a little more than 5 ounces of herbicide added to 143 ounces of water. Why only 143 ounces of water when up here it's stating we needed an actual 148 ounces of total mixture?
Because that included the water and the herbicide.
Correct. Good job. 148 minus the 5 ounces of herbicide. And so because there are 128 ounces in 1 gallon, this will mean adding 5 ounces of herbicide to 1.1 gallon of water. And that is what we have. So calibrating by volume, spray to wet or paint the plant with the spray paint. We're going to add water, no pesticide, to the tank and pressurize it. We're going to then record the number of seconds it takes to spray a representative plant. We're going to spray it thoroughly. You're going to get it good and wet. Spray water into a container for the length of time. Use this number to calculate the amount of water and product needed. So we're going to apply an insecticide to 18 azaleas in a plant bed. The labeled rate is 3 ounces of insecticide per gallon of water, and the number of plants to treat is 18. So you have a nice big shrub bed. Seconds to spray 1 average plant is 12 seconds, and the amount of water collected in 12 seconds is 10 ounces. To determine the total spray mixture needed, we're going to multiply the total number of plants to treat by the amount of water collected to treat 1 plant. So we have 18 times 10 ounces. Our 10 ounces is right here. Gives us 180 ounces. Convert the ounces to gallons, 180 divided by 128. We need 1.4 gallons. To determine the sorry about that, guys. But to determine the amount of insecticide needed, multiply the labeled rate by the total spray mixture. Our 3 ounces of insecticide from up here per gallon times 1.4 gallons gives us 4.2 ounces. Add a little more of 4 ounces of insecticide to 176 ounces of water. The 180 that we need minus the 4 ounces of product to treat the 18 azaleas. So very, very easy to calibrate these backpack sprayers. And that's why I love them, because anybody can be taught basically their first day on the job site
how to do this. You've hired that new employee, you can get them trained very, very quickly. And there's not as much damage that can be done with a backpack.
Hey, can you go back to that problem, please? So how do you come up with 12 seconds per plant?
12 seconds. Okay. So what it is, you're going to take your backpack and you're going to select one of the plants that very similar to all the plants.
I got you.
Similar
Okay.
size. And you're going to wet the plant thoroughly. You're going to just sit there and spray it, and you're going to time yourself how long it takes to thoroughly wet the plant, like the underneath.
Okay, so that's the criteria.
Yes.
The criteria is you're going to wet it until you determine that it is sufficient.
Thoroughly painted. Yes.
Okay.
That it is thoroughly wet, and it was, because in the slide here before, spray to wet or paint the plant with a spray paint.
I follow you. I was looking for something. I don't know. I follow you now.
Gotcha. And so you just pick one of those plants, spray it to wet, and you time yourself. It takes you 12 seconds. And then you take that 12 seconds and spray into like a measuring container. And for the 12 seconds, it took 10 ounces to actually spray that entire plant. And we had 18 azaleas. So 18 times the 10 ounces, we need the 180 ounces of total product or total spray mixture to get it, which is 1.4 gallons. So. Spot treatments and percent solutions. Calibration is not necessary for spot treatments. That's if like you're spraying some Roundup and it's saying, 3 ounces per gallon or whatever. The label rate will give you that information. Here they're saying like 6 tablespoons per 1 gallon of water to be sprayed wet. And actually spraying like weeds and shrub beds and things of that nature, you don't necessarily actually have to do it. But, if you wanted to, I recommend it. I would do it. But, a lot of guys just spraying weeds and shrub beds, they're not calibrating. So here, let's look at mix 3 gallons of a 2% pesticide solution in water. So we're going to convert our 2% to a decimal, which is just 2 divided by 100, 0.02. To determine the number of ounces of pesticide needed per gallon, we're going to multiply the rate per gallon, 0.02, by 128 ounces in the gallon. So that's 2.6 ounces. To determine the amount of pesticide needed, multiply the amount of pesticide per gallon by total spray mixture, 2.6 ounces per gallon times 3 gallons. We have 7.8 ounces. So mix a little less than 8 ounces of pesticide with a slightly less than 3 gallons of water. Very seldom do we see a problem like this in lawn care. Maybe if you're doing like a wettable powder, you would probably see this, but I'm sure, kind of like what we use, everything we're buying in liquid. And so we're not actually having to deal with that percent solution. Easy to do, but it's just not something that we do on a regular basis. Just not the products that we're using. Nozzle knowledge, just different types. Breaking it down, the nozzle body, the diaphragm, the strainer, the tip, the cap. You got the different nozzle types, a solid cone, a hollow cone, nothing there in the middle. Then you had the standard flat. Here is your spacing. Spray uniformly with the flat fan nozzles, adjust so that 30 to 50% of the spray pattern overlaps. Spray guns. To calibrate a spray gun, you'd want to divide 1,000 square feet by your swath width to determine the distance of the test course. Now, some of this information you're going to be able to find in like your core manual in North Carolina. And I know some of the states, I think South Carolina uses the same core manual, but I'm thinking across the states, they're trying to get this uniform core applicators manual. I know a lot of the stuff out west, very similar to what we use here on the East Coast. We're going to spray our test course with water using the technique you will use for your application and begin spraying just before you enter the course. You're going to record the number of seconds to spray the test course, average it 3 times, spray in the bucket the number of seconds from the 3rd step, measure and convert to gallons. The amount collected is equivalent to your spray gun output per 1,000 square feet. And for acres, multiply by 43.56 because there's 43,560 square feet in an acre. So very similar to a backpack. So let's say our swath width is 5 feet. We're going to mark a test course that is 200 feet long. That information will be given to you. And I'm thinking, I don't have my core manual here.
Anyway, get any bigger?
Sir? Your average for that swath width, you'll make your test course 200 feet long. 1,000 feet divided by the 5 is 200 feet. And so you're going to walk that course spraying it. Your average time in seconds to spray the 200-foot test course is 77, 79, 78, 234. And so you add all those together, it gives you the 234 divided by the 3, and your average is 78 seconds. Gallons sprayed into the bucket in 78 seconds is 5.25. Your output is equivalent to 5.25 gallons per 1,000 square feet, or 228.7 gallons per acre when we multiplied it by 4356. So note, if your calibration output is not within 5% of the labeled rate, adjust your walking speed, nozzle, or pressure, and recalibrate until your output outcomes within 5%. So we're going to look at, we have a couple problems here we'll look at that'll kind of explain that a little more. Hydraulic sprayers, like on the back of a tractor. Actually, we built one to go on one of our Walker mowers that works really well. Boom sprayer that kind of spreads out, folds in and out. These hydraulic sprayers, they can produce pressures up to 500 PSI. Application rates can vary widely. Small materials are applied at a rate of 1 quart per 1,000 square feet. Others may be applied at 100 gallons or more per acre. So the height of the nozzle above the ground determines your swath width, or the effective sprayed area nozzle. The height is usually 14 to 18 inches above the target surface. And these problems will kind of clear that up here in a bit. But, nozzle spacing, again, you want to spray to overlap. Pressure may be increased 4 times to double sprayer output. Adjust pressure to only make the small changes in your output. So a pre-calibration check, spray pattern, check all components, clean and correct your type. Clean the nozzles and screens with soapy water and a soft brush. Rinse the spray tank and partially fill with clean water. Pressurize your sprayer and flush the hoses and boom. Reattach the nozzle tips and then spray water over a paved surface. An overhead view of your spray pattern. Here, there's streaks in the pattern show the problems with the nozzle height, alignment, or your output. We would have to double check that. We'd have to see what's going on. So check your nozzle flow rate. With the container in ounces, catch the output from each nozzle for 20 seconds. So if you've got, 5 nozzles, 6 nozzles, whatever the size boom sprayer that you're using, you're going to have to attach a container to each. You're going to catch it for 20 seconds. You're going to add the amounts and divide by the number of nozzles for average output. If the output is 10% above or below the average, replace the nozzle. Repeat step 1 and use the results for the new average in steps 2. And here is the problem. We've got an output test 1. And so we've got an 8 nozzle sprayer that we're using. Nozzle 1 has 16 ounces that come out in 20 seconds. Nozzle 2 has 12. Number 3 has 15. Number 4 nozzle is 16 ounces. 5 is 16. 6 is 15. Nozzle number 7 is 14. And number 8 is 19. So I'm seeing problems automatically with number 2 and number 8. Because our average, when we add all these together, is 123. We're dividing by 8 nozzles. So the acceptable range is from 13.9 to 16.9. We want to be within 10%. 10% of the 15.4 plus or minus 1.54. So nozzles 2 and 8 should be cleaned or replaced because we want them to be between 13.9 and 16.9. Number 2 is below it. Number 8 is above it. So clean them, replace them, whatever it is, and then you retest. And so output test 2, we have the same 8 nozzles. This time we did 15. Look, number 2 got to 16. 3 was 15. 4 was 16. 5 is 16. Number 6 is 15. 7 is at 15. And number 8 is at 17. We add all these up. Our average, 125 for the total here. Divide by 8, we have an average of 15.6. 10% of that is 1.56. So the acceptable range is between 14 and 17.2.
Was this actual test numbers? Were this actual test numbers?
This was done by North Carolina Department of Ag. It was a problem they did.
Well, if 8's 19, that nozzle's worn out. So the flow rate's going to be higher with a lower PSI, and that affects number 7. So when you change it, you tighten up that PSI. That's why number 7 came up to 15 on the test.
Yes. Yep. Good point. Good point. That's right. Was this making sense to everybody?
Yeah.
Is anybody doing big tractor boom spraying or?
You.
Huh?
Nope.
Nope.
Backpack.
I love a backpack. I do, man. I do. Love it. All right. So we're going to measure our ground speed. We're going to mark a 200-foot course on a site that is typical of the surface and soil conditions of the area that we're going to spray. We're going to fill the tank half full. We're going to test which gear and RPM will allow the sprayer to maintain pressure on nozzles with a constant of 3 to 5 miles per hour. Drive the sprayer on the 200-foot course 3 times. Start far enough away to reach speed before your first marker. All right, our test course length is 200 feet. Our test runs in seconds are 31.5, 30.3, and 29.2. Average is 30.3 seconds. Add them all up, divide by the 3 times we did it, is 91 divided by 3, 30.3. So our miles per hour is equivalent to our test course run of 200 feet times 60 divided by the 30.3 seconds times 88. This is a constant. This is a formula to get it. So we should be running at about 4.5 miles per hour. So our collector output, we're going to collect for 1 minute or 30 seconds times 2. We're going to divide by the number of ounces per minute, OPM, ounces per minute, by 128 to find the gallons per minute, GPM. Measure the distance in inches between the tips of adjacent nozzles. This is your nozzle swath width. Determine sprayer output in gallons per acre by inserting the values from steps 2 and 3 and the miles per hour from your test course in the following formula. Our formula up here is gallons per acre is gallons per minute times a constant of 5,940 divided by miles per hour times your swath width. If output is specified in gallons per 1,000 square feet on the label, divide your GPA by the 43.56 because of 43,560 acres. You already know. So we're going to mix a pesticide with water. We're going to mix it with water to treat 2.5 acres using a boom sprayer. You already know that a label rate of 5 pints per acre and a spray volume of 30 gallons per acre. Our miles per hour that we did in the previous slide is 4.5 miles per hour. Our nozzle spacing was 20 inches, W. Our average nozzle output is 56 ounces per minute or 0.44 gallons per minute. To determine the sprayer output in gallons per acre, the 0.44 times the constant of 5,940 divided by our miles per hour times our swath width gives us 2,613.6 divided by 90 or 29. This output is within 5% of the label gallons per acre rate. That would be 1.5. So 5% of 30 is the 1.5. So no adjustment is needed.
So I got a question for you on that.
Yes,
Nozzle spacing is 20 inches.
Yes.
I know we're kind of moving through this real fast, and I can't dive down into this real deep with these numbers, but it's not giving any account to the height of the boom off the ground. I know it's supposed to be 14 to 18 inches. Is that we're just making an assumption that that's there?
Yeah, yeah, and basically, I mean, and this is, you know, this is just actually calibrating and seeing how much we're going to have to figure. So yeah, it hasn't really taken into consideration the height.
But
And if you're not, if you know, if your technician or the operator is, you know, at 20 inches, it's going to affect it differently. Yes. So, but to actually figure out how much we need in the tank and stuff, we don't really have to know the height for that.
I follow you now, because this is more geared towards the calibration. How much is coming out?
Yes, sir. Yep. And so to determine our total spray mixture needed, we'll multiply our target area by the sprayer output. And we have 2.5 acres times our 29 gallons per acre. We need 72.5 gallons total. To determine the amount of pesticide needed, we're going to multiply the target area by the labeled rate, 2.5 acres. 2.5 acres times 5 pints per acre. So right here, our label rate is in A. We're going to use 12.5 pints. And so we got 72.5 total spray mixture. We've got to subtract the 12.5. So we're going to need roughly 70.9 gallons of water to make that happen. So treating that 2.5 acres, we're going to add 12.5 pints of pesticide to 70.9 gallons of water to get that job done. All right, and so calibration for boom sprayers, make an adjustment if your sprayer output is not within 5% of the GPA on the labeled recommendation. Adjust the pressure, speed, or nozzles according to the guidelines in table 10.2. And here we have the table adjusting the boom sprayer. If measured output is within 5 to 10, increase the pressure to deliver more spray or decrease pressure to deliver less spray. If measured output varies from labeled GPA by 10 to 25%, adjust travel speed. Slower speed delivers more spray. Faster speed delivers less spray. If measured outputs vary from label rate more than 25%, change your nozzles and repeat the calibration process. Granular spreaders, you know, you got to establish your swath width, determine your application rate, and determine whether or not you're going to use drop or rotary. We're not going to talk about drop because very few people use a drop spreader anymore. I wouldn't own one. So we're going to kind of skip over the drops. But calibrating a rotary spreader, like I said, that and the backpack sprayer, that's all you need. That's all you need. And I mean, I know you're laughing there, but I swear, guys.
Right, you're right.
I mean, you can make some money with this stuff. I mean, you can.
Yeah.
It's boots on ground. I mean, you're there. You're in the weeds with it, and I like walking the properties. But calibrating a rotary spreader, very simple to do. You know, you're going to have boxes. You're going to space it out, and it's easier to look at this picture. I'm getting ready to show you. But you're going to put one box in the middle and space out the remaining on 2-foot centers. You're going to make 3 passes over the box. You're going to drive over it, come back around, drive over it, come back around, drive over it. You'll record the weight or you'll pour into jars. I'd rather pour into the jars. That's going to be marked with the box number. And the center jar should have the most product. It should taper off. Find the jars on both sides that have half the product of the one in the middle. So as they taper off, that's going to be your swath width. You can determine that really quick with the jar test. And so we have it right here. You know, the gentleman is making his 3 passes over the boxes. And then he's got the jars here. Jar number 6 is in the middle because they did 12. And he's actually found the spacing. So I think it looks like it was number 2 and let's see, what was it? It's on the next one here. All right, so better picture here. Actually used 9 jars. And so number 5 was right in the middle. And so number 2 and number 8 have exactly half of what number 5. And so the distance from there on 2-foot centers, 2, 4, 6, 8, 10, 12 there in the middle. We have a 12-foot swath width in between. That's how you get your swath width. All right, so you can do a before and after weight. You want to step one is you're going to weigh out enough product to load the spreader for a calibration test over a distance that can be easily converted to 1,000 square feet. That's table 10.3. This is directly out of your core manual. Step two, select a testing to deliver 1/2 the labeled rate. Note, spreader settings are not linear, so using the number half the number recommended on a product label will not result in half the application rate. You may need to experiment with your equipment. Step three, you're going to apply the material over the measured distance and weigh the product remaining in the spreader. The difference in pounds should be within 10% of 1/2 of the pesticide label rate. Adjust your sizing to the gate opening until your application rate is in the right range. This is directly out of the core manual. It's going to give you your effective swath width and tell you the distance in your length course. So we found out that ours was effective swath width was 12. So we need a test course of 84 feet. And this is the problem. So we're going to calibrate a rotary spreader to apply a turf herbicide using 2 passes over the treatment site. Labeled rate is 80 pounds per acre. Effective swath width that we determined was 12 feet. So our calibration course should be 84 feet. Beginning weight of the product is 2 pounds or 908 grams. The end weight of the product is 426 grams. The difference is 480 grams or 1.06 pounds. The spreader is calibrated to deliver 1.06 pounds per 1,000 square feet. Our rate per acre, rate per 1,000 square feet, times the 43.56 because we're dealing with the larger sites, or 1.06 times 43.56 gives us 46 2-point pounds per acre. This rate is higher than the rate needed of 40 pounds per acre. 1/2 the 80 pounds per acre. Adjust the spreader by reducing the gate opening until the rate falls within 10% of 40 pounds, which is between 36 and 44. And we were just a couple pounds over. So adjusting the gate would be real simple on that situation. Again, you got to do it. You got to calibrate it again, but you want to make sure you're right. So to determine the amount of granular insecticide needed to treat 2.5 acres, our label rate is 3 pounds per 1,000. Convert acres to square feet. 2.5 acres times 43,000 square feet is 108,900 square feet. To get the total amount of product needed, we're going to multiply the area by the application rate. 108,900 times 3 pounds per 1,000 equals 326,700 pounds divided by 1,000, or 326 pounds. So we're going to need 6.5 bags to complete this project. And to actually to do it, figure 10.16, to use the right angle method, make 2 passes at 90-degree angles. I prefer figure 10.17. Use the half width method to do it in the parallel lines. Passes 1/2 the effective swath width. And that concludes part 1 of applying the correct amount of pesticide. If you guys want to go ahead and actually take a 10-minute break, and we'll get started around 8:10 here, and we'll look at the next slide deck.
Sounds good.
Thank you, sir.